Yeah, here I'll try to explain what is conceptual problem solving in physics through two examples. So I propose to come out with videos covering such problems in various other topics. So here I have got two problems. One is instead of explaining what is the conceptual problem solving, I'll demonstrate what is conceptual problem solving. So look at this problem, the first problem. Here the problem is to find out the work done on a particle of mass m by a force k. The expression is given. K is a constant. When the particle is taken from the point A0 to the point 0A along a circular path of radius A about the origin in the xy plane. Here you can see that there is a circle. Let's change the color. So here you have a circle. Now let us take this as the origin is 0, 0, and this is A0, and this is 0A. Now the particle has to be taken along this path. We have to find out the work done by the force which is acting on the particle as it moves from A0 to 0A. So here we can see the solution which is given in this example, which I picked up from on site. Simply we know that the work done is Fxy into d. Actually it is a line integral. This is a line integral. So we have to say Fxy, then we have to go along the path. Let me call the path is dl. And the xy are the points which lie on the path. Points on the path. See, actually, when we have such problems, this has got a circular symmetry. So it's better that we go into r theta, that is a polar coordinate system, and then we can work out the problem, because the r is constant here and it is only theta which varies. But we will find that even that is not required for us to do the integration. We don't have to do the integration. When we look at the force, we find that the force is nothing but it is given, it is going around the circle, which is given by x square plus y square is equal to a square. When we plug in that, we will find the force is nothing but, here we have x square plus y square 3 by 2. So here we have got a square. So what we find is k by a cube and xi plus yj. So this is again going on the xi and yj such that they are on this arc. So simply we can write this as k a cube r. That is, or in fact we can write it as a, which is changing. This is vector a. So we can find as the particle moves along the path, this is the direction of the force and this is the direction of the motion of the particle. And we know that always the motion of the particle is perpendicular to the direction of the force, and we know the work done in such case is 0, because the force is perpendicular to the path. So here we have seen that without having to integrate, if you know the concept, then we can get the solution. So if you have enough practice by mere observation, one can just get the answer, because the speed is important in competitive examination. And then we look at the next problem, which is 4 persons ABCD. So they are actually going along a path. So this ABCD. Now it says this is the length d, and they start moving with the uniform speed v each one of them. So always every person starts moving with same speed v such that each one faces other always. The person will meet after time. So that is, this person will start looking at this and will move. this person will look at this fellow, and this fellow will look at this fellow, this fellow will look at this way. That means after some time, what would happen is this fellow, suppose, goes through a small distance, this fellow would have gone this distance. So as he walks, he will be looking at this fellow. So then it looks, the problem looks quite complex. So if you know the basic concept, then it becomes very simple. We can see that after a small time, then what will happen is, if you recognize the fact that, let me put the same distance, if you recognize the fact that they are always walking perpendicular to each other, this angle is 90, this is 90. So that is, they are always working uh, on a square. Ultimately, the size of the square will reduce over a period of time, and finally they will meet at the one point. That is how it will happen. So because they are walking perpendicular to each other, so this motion actually has no effect on the speed of the each person to meet the other person. That is, simply we will find the time taken will be d by v, because at every instant of time they are in a square. So that is, if you realize that it is the direction is always perpendicular, then the solution is simple. So we'll try to show whether it is true or not. See, there is another way of doing. First is, let us take the square. Now after some time, this is a thing. So if you take this angle, let us say alpha, this is beta, alpha is equal to beta. Now let us say gamma. Okay, so alpha plus gamma is 90. So beta plus gamma is 90. So this angle, if you take theta, because the total is 180, so theta has to be 90. So they are always perpendicular. So there is another way of doing it. Of course, not the best way. This is the best way, so you can get the answer straight away. So the other way is, let us take after time dt, the distance traveled is u dt, and this is u dt, and this is d minus u dt, this one. So the distance between the two, a and b, if this is a and b, distance between the two after time dt is this square plus this square. So square of the distance, let us say s square, is d minus u dt whole square plus u square u dt whole square. Let me put it this way. So that is the distance. So what we do is, for dt small, this we neglect because this is a second order term. Now here we are having d square minus, yeah, d square minus u dt whole square, same thing. We will neglect this, minus 2u minus 2u d dt. So this is the distance square after time delta t. So this we can take out, this we can neglect. Then we write s square is equal to d square, we take out. Then we have 1 minus 2u by d into dt. Even though it is not necessary for doing all this in this particular problem, but this exercise helps you to use this method of approach in some problems. So that's why I'm discussing here. So now this is, now when we take the root of this, s is equal to d into, this is 1 minus u by d dt. Because for small, because u by d is less than 1, so this we can write binomial expansion, and we get this. So this will be simply, I'll write it on the other side, s is equal to d minus u dt. So after time dt, the distance traveled is d minus u dt. So for traveling d distance, simply we'll have time is d by u. So that is how the conceptual understanding helps one to solve the problem very quickly and gives an insight into the physics of the problem. So, but actually, in a problem like this, someone could actually arrive at an answer without understanding. Someone may write d by v is the answer without realizing how actually it is d by v. So, in some examinations, a mere answer will not help. The examiner wants to explain how one has arrived at the answer. In such a case, understanding is crucial. Hope this helps the student to gain insight into a conceptual approach to problem solving in physics.